slides give us a little bit better illustration of what's happening with the asthenosphere. So with the asthenosphere, this illustration gives us a really clear illustration of these convective currents where we've got hot air moving upwards, moving across the underside of this case of the ocean crust. It's at this zone it's cool, so it starts to adhere to the underside of the ocean crust. So we're sort of gluing the underside of the mantle with the ocean crust, and they're going to move together across, and then they're going to rotate back down at some point. So we've got lots and lots of these convective currents happening across the entire planet underneath the surface of our planet. So lots of these convective currents are happening. The really big ones that we understand the best is that we know we've got uplifting happening in the middle of the Atlantic along something called the Mid-Atlantic Ridge. And that Mid-Atlantic Ridge is creating a fissure zone. And so at that fissure zone, we're able to stretch the ocean matter out, and some matter is being ejected to the surface of the the ocean crust right here. With that, then, we're pushing some of that landmass in one direction and some of that landmass in another direction. The way this is oriented, if this is north up here, this would be the North American plate, and this would be the Eurasian plate over here. Now, I need you to forget that here for a minute, because the way this is drawn doesn't work with this being the North American plate. Okay, so I want to be very clear with that. This is a fictitious illustration here. All right, and on this fictitious illustration, what we have drawn is a an active margin right here, where this part of the crust is pushing into the asthenosphere, and in doing so, it's driving matter into this lower zone. Across here is the passive margin. So the ocean crust and the continental crust are fused together. The ocean crust is not pushing or diving, subducting, which is the technical term, underneath to create an active margin. So we have a passive margin here. So these big zones of hot matter lifting and cooling as it rises, and then cold matter rotating around and then heating up as it goes back towards the central part of our Earth, then is the genesis of how our planet's volcanoes occur, where we've got collision zones that are going to create folding and faulting, and where our continents and our oceans are located for the most part. That asthenosphere, as I said, drives plate tectonics. And with that, as I had noted in the previous slide, is we've got active and passive plate margins. Now, where we do have an active plate margin would be the west side of the Pacific Ocean. And along that west side, we've got places like Japan and the Philippines, and then all the way down to New Zealand. We've got this subduction zone, but in the Pacific, we do not have a spreading center. So the artists have taken liberty to try to draw everything into one location, so it's easy to comprehend what's happening here. So with asthenospheres, what we're getting is volcanic creation. So we're pushing matter into the surface of the Earth, just like when you stuff more and more things into a confined place, there's less and less volume available for that to be pushed in. So at some point, stuff's going to be emitted back out, and where it gets emitted back out is where we're going to generate a string of volcanoes or a puncture of volcanoes happening. The other location, but to a lesser degree, where we're going to get volcanic activity happening is in these spreading zones, where they're divergent zones. The folding and faulting is going to occur where land masses push against each other, and we pop land forms up. So think of the Rocky Mountains as a good zone here. We don't have any volcanism there, but we've got parts of a large continent which are being pushed into each other, and then we get uplift happening.